Voyager 2 is a space probe launched by NASA on August 20th, 1977, to study the outer planets and interstellar space beyond the Sun's heliosphere. Voyager 2 flew by Neptune on August 25th, 1989. It's been almost 33 years since the flyby, and what it discovered will surprise you. Voyager 2 went on to explore interstellar space, but what it discovered on Neptune will still be witnessed from time to time. The Hubble Space Telescope also observed the same thing on Neptune, and it is something that is dark and massive. In this video, we'll talk about the terrible occurrence on Neptune. Make sure you stay tuned to the end of the video to know about these terrible occurrences. Before we begin, welcome to Discover Space. If you want to be a part of our space journey, don't forget to click the subscribe button and hit the notification bell next to it to be the first to know whenever we upload a new video. Neptune is the 8th planet from the Sun and the farthest known solar planet. It is the 4th largest planet by diameter, the 3rd most massive planet, and the densest giant planet of our solar system. It is 17 times the mass of Earth and slightly more massive than its neighboring planet Uranus. Neptune is denser and physically smaller than Uranus because its greater mass causes more gravitational compression of its atmosphere. It is referred to as one of the solar system's 2 ice giant planets. On August 25, 1989, Voyager 2 made its closest approach to the planet Neptune. Flight controllers chose the optimal path for Voyager 2 to take through the Neptune Triton system after conducting numerous computerized test simulations of trajectories through the Neptunian system in preparation. Voyager 2 was directed into a route of roughly 4,950 kilometers above the North Pole of Neptune by mid-course corrections because the plane of Triton's orbit is inclined substantially with respect to the plane of the ecliptic. In 1989, Voyager 2 completed a close flyby of Triton, the largest of Neptune's 2 initially identified moons, passing within around 40,000 kilometers 5 hours after it made its closest approach to the planet. It found numerous cryovolcanoes there. Triton has a young surface, active geology, and a small number of impact craters. Its atmosphere is extremely thin. On average, only 40% of Triton's surface could be seen by Voyager 2. Voyager 2 also discovered 6 new moons, including Despina, Galactia, Laurisia, Proteus, Naiad, and Thalassa, as well as previously unknown Neptunian rings. Voyager 2 also discovered something that is dark and massive, which were later observed by the Hubble Space Telescope. So, a series of Hubble Space Telescope observations of the gigantic planet Neptune revealed that a massive dark storm raging in its northern hemisphere was traveling south until it suddenly made a sharp U-turn and started moving back north. In addition, it might have given birth to a young dark storm in the process. The term ice giant refers to Neptune, which is essentially a huge ball of hydrogen and helium gas that also contains a lot of methane, ammonia, and other molecules. For historical reasons, planetary scientists still refer to these molecules as ice, even though they are gaseous. Scientists were shocked by the images Voyager 2 returned after passing by Neptune in 1989. It revealed a massive oval dark storm the size of Earth in the planet's southern hemisphere. It has been named the Giant Dark Spot because it produced the fastest wind ever recorded in the solar system, reaching wind speeds of an astonishing 2,100 kph. But the spot was gone when Hubble observed Neptune in 1994. Poof! Disappeared just like that. There is no doubt that Neptune's storms developed over shorter periods of time than those of Jupiter, where the giant red spot had lasted for centuries at least. For example, a smaller dark patch in Neptune's southern hemisphere was discovered in the same 1994 Hubble observations. This dark spot must have formed between the Voyager flyby and the Hubble images. Since then, Hubble, the only telescope with sufficient resolution to see these structures from so far away, has discovered a number of other dark spots. They develop at mid-latitudes in both hemispheres and tend to move in the direction of the equator. But they face certain death if they do that. As a result, the Coriolis effect, which states that the speed of a planet's rotation varies with latitude, with a maximum at the equator and a minimum at the poles, air flowing outward from a large high-pressure system or inward towards a low-pressure one will cause the system to begin rotating as it meets air moving at different speeds to the north and south. As these Neptunian storms move in that direction, the Coriolis effect weakens closer to the equator, which causes them to shatter. The majority of these storms appear to end up there, but it did not happen this time though. In September 2018, Hubble observed a mysterious storm in Neptune's northern hemisphere. The entire continental United States could easily fit inside this enormous, over 7,000 kilometer wide storm, which was seen by traveling south. However, inspections made in January 2020 revealed that the storm's southern movement has been reversed and it was now once more headed towards north. Neptune is a mystery to scientists who study it. There's also this. 2 other mysterious occurrences have been observed in connection with this storm. One is that it seemed to create a smaller dark storm at the time. It changed its mind and then began moving north again. This is predicted to occur by some computer simulations of Neptune's atmosphere, particularly as a large storm begins to dissipate towards the equator, when it can drop smaller vortices. Although it wasn't directly observed, since the observations were spaced too far apart, it's possible that this is what happened in this instance. It may have shifted course due to that, according to certain theories. Strangely, unlike almost every other dark storm, this one doesn't have bright white clouds circling its edges. These are methane ice crystal clouds, which are extremely reflective and appear white in images. Winds carry methane gas up the atmosphere. Here, the methane cools and crystallizes in the ice. When water-rich air pushes up the side of a mountain, cools and condenses to create clouds. Orographic clouds occur, and they are typical on Earth. Images from 2019 showed the Neptunian white clouds, but they vanished at the beginning of this year. The strange behavior of the dark storm might be related to this. Due to its distance, Neptune is challenging to study and understand, and despite its enormous size, it nevertheless appears quite little in our telescopes. Additionally, it is challenging to understand what's happening there due to the atmosphere's rapid changes. Since an orbiter may spend years initially at Uranus before moving on to circle Neptune, scientists are particularly interested in developing a mission specifically designed to explore the outer planets. Sending a probe that stays on a planet for a long time is the greatest approach to learn about it, as we discovered with Cassian at Saturn. Features come and go, conditions change, and perhaps most significantly, when researchers discover new phenomena, they may direct the spacecraft to investigate more closely. While discovering new things is crucial, a focused objective allows you to remain and possibly discover their origin. And that is why scientists are planning a mission known as the Trident mission. The space mission was proposed by NASA's Discovery program in 2019 to explore the outer planets. The plan includes for flybys of Jupiter and Neptune, with a particular emphasis on Triton, Neptune's biggest moon. The mission has the backing of NASA's Ocean Worlds Exploration program and aims to contribute to the answer of some of the questions raised by Voyager 2's flyby in 1989. Trident makes the most of a limited observational window that allows evaluation of changes in Triton's plumb activity and surface characteristics. Since the previous encounter of Neptune-Triton by Voyager 2 in 1989, it has taken advantage of an effective gravity-assist alignment of Jupiter and Neptune, which happens once every 13 years. Trident would be able to gather a nearly complete map of Neptune's moon during its sole flyby in 2038, thanks to advancements in high-resolution imaging and Triton's special orbital configuration. Trident would go through Triton's thin atmosphere at a distance of 500 kilometers, sampling the ionosphere with a plasma spectrometer and taking magnetic induction measurements to determine whether an interior ocean might be present. If the Vulcan is not used instead, the Atlas V401 is the launch vehicle suggested for Trident. The suggested launch window, which occurs once every 13 years when Earth is perfectly aligned with Jupiter, will be October 2025 with a backup launch date in October 2026. In 2038, the spacecraft will go directly to Triton for an extended 13-day encounter by using Jupiter's gravitational pull as a propellant. That's all for this video. Thanks for watching. If you enjoyed, don't forget to like the video, also subscribe to the channel and hit the bell icon